A sudden surge of cyanide and nickel, but no iron in the gas surrounding 3I Atlas. Coincidence or cosmic clue? Hold on to your seats. The telescope data on 3I Atlas just threw a curveball at scientists. A recent study using the powerful Very Large Telescope reported something astonishing. The instrument detected a rising amount of nickel without accompanying iron in the gas cloud streaming off this mysterious interstellar object. Why is this so jaw-dropping? Because in natural cosmic explosions, like supernovae, iron and nickel are always found together, a cosmic tag team. But here, iron is conspicuously absent. Nickel without iron is a classic hint of industrial processes, particularly those used for making nickel alloys. Suddenly, 3I Atlas isn't just an oddball comet. It's at the center of a brewing scientific controversy. Is this object a product of nature? Or could it be a relic of alien technology? Let's dive deeper. Here's where it gets especially intriguing. The researchers suggest the nickel might be forming through a chemical pathway known as the nickel-carbonyl channel, a process essentially unheard of in comets, yet standard in industrial nickel refining here on Earth. Naturally, this raises eyebrows. What could possibly be driving such a bizarre chemistry in the depths of space? According to the data, as 3I Atlas approaches the Sun, the rate at which nickel evaporates from its plume soars dramatically, hitting about 5 grams per second at a distance of 2.8 astronomical units, AU, which is 2.8 times the Earth-Sun gap. As it gets closer, nickel production accelerates, following a steep power law, with an index of negative 8.43, give or take 0.79. And this is the part most people miss. It's not just nickel. Scientists also detected cyanide, CN, another rare compound, gushing out of the comet at about 20 grams per second at 2.85 AU. And its release rate climbs even more steeply as the object nears the Sun, scaling up with a power law index of negative 9.38, plus minus 1.2. But why stop there? Additional anomalies have piled up thanks to observations from the SpareX Space Observatory and the Webb telescope. They found that the gas cloud surrounding 3I Atlas is overwhelmingly made of carbon dioxide, about 95%, with precious little water, only 5%. For reference, typical comets are water-rich. It's what makes their tails so snazzy when sunlight vaporizes their icy surfaces. Here, though, something very odd is going on. Here's a controversial twist. Some have speculated that maybe the visible mass comes not from a gigantic solid core, but from a dense shell of dust that reflects sunlight. If so, the dust should have formed a dramatic tail blown away from the Sun by radiation pressure, a classic comet look. Yet, when astronomers scrutinized images from the Hubble Space Telescope, there was no obvious tail stretching behind 3I Atlas. The plume seemed to spread not just away from the Sun, but sideways, a pattern that begs for answers. Alternatively, what if the sunlight's reflection is mainly from the object's solid surface rather than from dust? In that scenario, 3I Atlas could be 1,000,000 times heavier than the previous interstellar visitor, 2I Borisov. If this is true, we'd expect to have found countless Borisov-sized objects before seeing anything as massive as 3I Atlas. Unless, of course, this object is no random wanderer, but is following a precisely arranged trajectory. Complicating things further, the object's path is astonishingly aligned with the ecliptic plane, the flat circle where planets orbit, which some researchers interpret as suggesting intentional, possibly technological targeting of our inner solar system. This claim is bound to spark debate. Are we seeing signs of purposeful design, or is this simply a statistical fluke? As I write this from Copenhagen, where I recently gave a talk at the Current Themes in Astrophysics and Particle Physics 2025 conference, a gathering attended by Nobel laureate David Gross and other top minds, I'm struck by the weight of historical context. Copenhagen, after all, is renowned among physicists as the home of the Copenhagen interpretation of quantum mechanics. Sitting in the same auditorium where legends like Niels Bohr, Werner Heisenberg, Wolfgang Pauli, and Lev Landau once held court, I couldn't help but reflect on the way revolutionary thinking was fostered here, even as I squirmed on the hard wooden benches. Back then, creative deviation was celebrated, not roasted in the echo chamber of online comments. During my presentation, a two-part lecture covering black holes and interstellar objects, the room buzzed with genuine curiosity. The 3i Atlas discussion especially drew spirited questions, including ones from Dated Gloss about whether we should attempt to make contact with 3i Atlas, what its emissions mean if it is technological, and if hints of non-gravitational movement provide further evidence of anomaly. The conference organizers called the talk wonderful and refreshing, and for once in my long career, I felt the joy of authentic, open-minded inquiry, the very spirit that drove me into science all those years ago. But the story's not over. On October 3rd, 2025, 3i Atlas will come within 29 million kilometers of the high-rise camera aboard the Mars Reconnaissance Orbiter, which should snap images at a spectacular 30 kilometers per pixel. These pictures might finally let scientists tease apart the brightness contributed by the object's nucleus versus its fuzzy coma, giving much clearer clues about its actual size. In another bold suggestion, David Gross recommended that astronomers use radio telescopes to listen for any possible transmissions from 3i Atlas. Could this be an accidental meeting with extraterrestrial technology? After all, for over a century, humanity has been pumping radio waves out into space, waves that could have alerted distant intelligences. If 3i Atlas left the Oort cloud some 80 years ago, roughly when radio communications became the norm on Earth, the timing would be uncanny. Is it just a coincidence that the first nuclear test occurred exactly 80 years ago, too? Here's a dilemma and a touch of controversy. If 3i Atlas is ultimately revealed as an ordinary CO2-laden comet, we dodge the risks of a close encounter with alien tech. But isn't it possible humanity could use a wake-up call? Something to jolt us out of complacency and prompt us to re-examine our collective trajectory. During the coffee break, I got word from mathematician Alex Lipsaska about his recent discovery of 3 new symmetries in the mathematics describing black holes. In a moment that might spark debate among scientists and technologists, Alex asked the AI system ChatGPT to uncover these symmetries, and was stunned when it swiftly succeeded, working from old data, even though his findings weren't yet published. Have we?